Hi guys, welcome back to my channel Programming with Pirai. In this video, we are going to see about a Leetcode question number 508. Most frequent subtree sum. Given the root of a binary tree, return the most frequent subtree sum. If there is a tie, return all values with the highest frequency in any order. The subtree sum of a node is defined as the sum of all node values formed by the subtree root at that node, including that node itself. Okay, so they're asking us to find the most frequent value. Now, let's take, first of all, what is meant by subtree? We want to know what is meant by subtree, right? Okay, now, let us take this node 10 as our initial node. So I can say this all value is my subtree of this 10, of this node 10. Okay. Now, if I take this 5, then I can say this all node is a subtree. Can you understand this? Okay, if I take this 2, I can say this all node is a subtree. Yes, now if I take this 3 alone, it is a subtree. And same like it is a subtree, it is a subtree, and it is also subtree. Understand this? So this is the definition of subtree. Subtree is something like a node and its descendants. So that's called a subtree. Fine. Now we want to find that sum. Okay, let us take this first example. Now in this first example, I can say this whole tree is a subtree. Yes. Now this one node is a subtree, and this one node is another subtree. So I can say this 5 plus 2 minus 3 is one of the subtree sum. Yes, which is equal to what? Which is equal to something like 3, 1, 4. Yes, then 2 is another subtree, 3 is another subtree sum. So I can say 4, 2, 3 occurred one time. So 4 occurred one time, 2 occurred one time, 3 occurred one time. So what is the most frequent element? There is all are same time. All are occurred same time. I can say the output will be 2, 3, 4. You can also return in what? 3, 4, 2 in any order. You can return in any order. But this would be my output. Okay, fine. Now, let us take the second example. This whole subtree can be one of the subtree. And this 2 alone can be a subtree. This minus 5 alone can be a subtree. Okay. Now, 5 plus 2 plus minus 5 is equal to what? 2. Yes. Again, this only subtree is what? 2. Again, this only subtree is what? Minus 5. So, from this, I can say 2 occurred 2 times. Minus 5 occurred only 1 time. So, from this, what is the most frequent? 2. So, I want to give the output as what? 2 alone. Can you understand this? Yes. Now, how to do this? Okay, fine. I want to keep track on what? All subtrees, right? Fine. So, let me explain you. First, I am at this position. I am this and this dead. Okay. I want to keep track on all elements below it. I want to keep track on all elements below it and find that sum and keep here. Can you understand this? Okay. Now, I go to here. Now, I traverse all down elements and take the sum and keep here. Yes, again, I go to this 3, then go to this 1, then go to this 2, and go to this 0, and go to this 4. And I will find all sum of my subtree. Right? And I will take the most frequent element and keep this as a result. Can you understand this? So, this is our first approach. This is a brute force approach. Now, what is the time constant space of t? I can say time constant will be what? N square. Why? Because we are placing a pointer one node and we are going to each and every descendant. We are going to each and every descendant and taking it. And what space of t? This vertex. Can you understand this? To traverse itself, this is a time and space of t. Okay, first we can say how to find the subtree sum. First we are going to focus on how to find a subtree sum. Then we can focus on how to take the maximum among them. Okay, first we can focus on how to take the subtree sum. Okay, now observe carefully. This 3 and this 1 is included in what? This pi subtree. So pi subtree is what? Sorry, pi subtree sum is what? This 3 and 1 are included. Okay. In 10 also, this 1 and 3 is included, but this 5 is added, right? And also, 2, 0 and 4 is added. So from this I can say the subtree of the 5 is also the subtree of this 10. So, subtree of a child is also the subtree of the parent, right? So, I can say we want to take that also in our result. So, going from top to bottom is inefficient. Rather than we can go from bottom to top. Okay, let me redraw it and let me explain how to find a subtree sum. See here, initially our tree is like this. Now I place my pointer here. Now and go here, here, and reach the end. This is what? A post-ordered DFS transfer. Post-ordered DFS transfer. Okay. Now at this point, it is what? A null. So it is null, so return 0. And it goes to right. And it also null, so it returns 0. Okay, no. What it signifies? By tree, there's no tree. Its left subtree value sum. The left subtree sum is 0 and right subtree sum is 0. And it returns what? Take myself also. So it is what? 3 plus 0 plus 0. It returns what? 3. Can you understand this? Okay, now I go here. Here also it is null. It is also null. This both value return what? 0. And it returns what? Myself 1. And my left subtree sum is 0. My right subtree sum is also 0. So it is what? 1. So for this 5, what should I return? Myself it is 5. And my left subtree value is what? Sum is what? 3. And my right subtree sum is what? 1. So I should return what? I should return 5 plus 3 plus 1 is equal to what? 8 plus 1, 9. Okay. Now again I will go for the right subtree. Now again go to the depth. Now it is null. So it returns 0 and it is null. It also returns 0. So here this 0 returns what? Myself 0. My left subtree, right subtree sum is also 0. So it returns 0. Okay. Now I am go to here. Then it is also null. It is also null. So it also returns 0. It also returns 0. Now this 4 returns what? My left subtree sum is 0. My right subtree sum is 0. And myself it is 4. So it returns 4. Now this 2 returns what? This 2 returns hey, my value is 2. And my left subtree value is 0. My right subtree value is 4. So add this all. So it will be 6. And this 10 returns what? Hey, my left subtree values sum is 9. And my right subtree sum is what? 6. And add myself. So 10 plus 9 plus 6 is equal to 25. So let us add it. 5 plus 10, sorry, that's 5 plus 10, it is 15. 15 plus 4, it is 19. 19 plus 2, it is 21. 21 plus 4, it is 25. So we got the answer, right? 25. And also, in each and every step, we got the individual subtree sum. Can you understand this? See here, hold on. For this 3, we got what? 3 plus 0 plus 0. For this 5, we got what? 3 plus 1 plus 5. And for this 10, we got what? This 9 plus 6 plus 10. Can you understand this? For each and every individual node, we got the answer. Yes, for this last, for this node 10, we got all the sum value. Can you understand this? Through which we can take the subtree sum. Can you understand this? See here, we took the subtree sum. Like for this 3, we got 3 and let's take with 3. Then for this 5, we got what? Sorry, for this 1, we got 1. Then for this 5, we got what? 3 plus 1 plus 5 is equal to 9. So we got 9. Okay. For this 0, we got 0. For this 4, we got 4. For this 2, 0 plus 4 plus 2 is equal to 6. Then for this 10, we got what? 9 plus 6 plus 10 is equal to 25. So these are the possible values we got, right? Can you understand this? 1, 2, 3, 4, 5, 6, 7. So 7 values and 7 nodes totally we got. Okay. And for this example, we written what? We just written all values. These all values because these all get what? A frequency of 1. So we written all values. Now hope we understand how to take a subtree sum. A subtree sum. So we successfully completed the first problem. Okay, now what is the second problem? We want to take the maximum. Okay. Take example. I counted each and every value. Take for example, let us take 1 is 1 time, 2 is 4 time, and 4 occurred 4 time, and 5 occurred 3 time. So this is my value. Okay, this is my dictionary. And I counted each and every node here. Each and every value occurrence. That's the subtree sum. That subtree sum frequency is here. Okay. How to take the maximum? So to take the maximum, first I want to take the maximum sum, right? I want to take the maximum possible sum. So I can say this 4 is the maximum value, right? So I want to take the max of my hash maps value. Upon all values, what is the maximum value I can take? So it is what? 4. Now I will traverse one by one. Okay. Now, first of all, whether this value is equal to 4, no. Whether this value is equal to 4, yes. So I will add this to the result. So initially our result is for 2. Now again, I'm going to check whether this value is equal to 4, yes. So I added it to the result. Okay. Now again, I will take this value and check whether it is equal to result, yes. So I add this value. Sorry. It is not equal to this maximum, right? So I will not add this value. Okay. Now finally I got the answer is what? 1. So this may output. Can you understand this? So our second problem is also solved. So at last, I can say these are the 2 procedures we want to take in your hand, right? So you want to do a down or bottom up approach. Bottom to up approach. First go to deepest node. Then while backtracking, just return the left sum, right sum plus that node sum. Can you understand this? So this is the procedure. By doing this, we can get the individual node and its subtree sum. Can you understand this? Okay. Now, what is the time constant? I can say time constant will be O of n. First of all, O of n. And also, see here, inside this dictionary or this task map, we are just inserting it and we are taking it, right? So to do this, we want a log n type. At a very worst complexity. Okay, and also, what is the space quantity? Can say space quantity will be O of. I'm putting each and every node value inside my dictionary, right? So it will be n plus for the recursion we want h. So this is my space quantity. So this is a time and space quantity analysis. Now let us see the code here. See here. First of all, doing a DFS traversal, the postal traversal. If not root, then return 0. Else L is equal to DFS of root dot left. So I'm going to left subtree. Then R is equal to DFS of root dot right. So I'm going to root right subtree. Now value is equal to L plus R plus root dot parent. So what it signifies? It signifies I'm just added my left subtree sum, right subtree sum, and also myself. Okay. Now, if that value is not in my dictionary, then what should I do? Dictionary of that value is 0. So keep that as our key and initialize the initial count as what? 0. And regardless of whether it is in the dictionary or not, do a operation what? D of value plus 1. Can you understand it? We are just incrementing our count by 1. Now, return that value here for our next parent, because if a node's whole subtree is a left subtree of some parent, we want to return that spot as a left subtree with the above parent. Can you understand this? Okay. Now, then we are just taking a dictionary again. Just initializing here, right? Here we are initializing such that we can use inside this function. Can you understand this? In Python, we can use like this because it is right in the same function. But you are using a Java, we want to use in a different function, right? So just make this as a parameter. Just send as an argument. Okay. Now TFS of root. Okay. Now M is equal to maximum among the values of the dictionary. So I'm taking the maximum values in the dictionary, which is what's the maximum frequency I can attain. And if I'm passing the whole dictionary, and if the value of the current dictionary element is equal to the maximum, then what should I do? I should take that key and append to the result. So key is what? Key is the I. Can you understand this? So at last, I will return the result. Let me submit it. Yes, it is submitted. Thank you.
We have done.
What's going to be like?